All right, we are going to go ahead and get started. I want to thank everybody for attending today's session. We will, if I didn't say this, we will be recording today's session so that we can have it up on the web and available to your teammates and other competitors in this year's competition. And so this is our, I'm trying to think, I believe this is what, number 3, 4, something of that nature in our series of various webinars. And today I'm excited. The subject is on RockSim. And so I am happy to introduce Mark Abotossaway. Mark is an alumni with First Nations Launch. He competed several years ago, 2 years in a row with the University of Minnesota Twin Cities, and also participated in Student Launch. And then afterwards went on to work with Boeing as a structures engineer and has given back to our program, and just really excited to always have him be a part of First Nations Launch and help us to be a successful program. With that being said, Mark, I am going to go ahead and let you take the screen, and we do not see you yet, so if you could pull up your video, that would be great.
Hi. I was trying to stay off video, but all right. Good afternoon, everyone. I guess we should get going. This is quite a presentation we have. We got a lot to cover today. As Christine said, my name is Mark Abotossaway, and I am a Ojibwe from Manitoulin Island, Canada. I'm Ojibwe First Nation, and I'm the advisor liaison this year. In the past, I was project assistant for a number of years, and then I was also a student competitor, leading a couple teams in FNL and other rocket competitions. So let's dive right in here. This is my first time presenting on a Zoom. So so bear with me as I figure this out. So you guys see my screen?
Yes.
Yes. Yes, we see it, but you might want to put it in presenter view because we see in the presentation, because we see all of your notes on the left-hand side.
All right. So we'll be jumping kind of back and forth between the PowerPoint, and then we'll also jump to RockSim itself when necessary to continue the demos. So this is the RockSim webinar. So what we're covering today, presentation overview. So how to acquire and install RockSim. So it's apparent, or apparently there's been some issues with the teams acquiring and installing RockSim, reviewing your proposals. Some teams are still using the Open Rocket, which we've done in the past, which is acceptable for now, but we'd like you to get RockSim and get the license. So we'll talk about the interface. We'll talk about loading a model, importing a rocket. Sometimes your rocket kit isn't always in RockSim library, so you have to figure out how to import it. Set up and running simulations, analyzing simulations, and then modifying the simulations. So there's a lot going on. Mastering the first two, setting up and analyzing before you modify is kind of the key. And then there's a couple other important items we'll cover as well. So the simulation process. So every engineering project begins with simulations. So I was a structural engineer for the Boeing company. So we use simulations for years to kind of, create our product. Aaron Ashley, who's also on, works for Raytheon, can tell you the same thing. Engineers at Raytheon Missile Systems use a lot of simulations. It tells you how the vehicle will perform. You can use the simulation to make design choices, right? And then it's also an iterative process. So don't think it's one and done, or one and you have to stick to it. You kind of update and change as you go. And then it continues up to the build and then past the build as well. So once you have a final product, and it's the same thing in engineering world, you kind of compare back what you built and how it performs to what you simulated. Acquiring and installing RockSim. So hopefully many of you have already got the RockSim trial. There's a free 30-day trial. There's a link. Hopefully that'll be shared in the chat. I believe this PowerPoint will be made available or the video for later use. So then your license can be obtained at a later date. So don't worry if you don't have a license or you haven't figured out how to get the license yet. Just go ahead and get the trial, start playing with it. Your faculty advisor should be consulted before purchasing a license. So make sure you guys figure out, who's paying for what and how it's going to all be reimbursed, whether the student pays for the license or the faculty advisor buys the license and gives it to the student. And then you'll get an activation code. And then to get the discounted rate, the purchasing individual must use the TARC discount page. So Apogee Rockets has a lot of different licenses for a lot of different kind of versions of Roxim. So make sure you're in the Roxim educational TARC page. So you can see there's a screenshot there. It's a $20 license. It's a temporary license. It'll expire in August 31st of next year. So if you find you're doing a lot more rocketry or you get into it, you might want to buy a personal license on your own. These are to be installed on personal computers. We assume because you're all working virtually, it's going to be installed on your personal laptop. It's also, you can get it from Mac as well, not just PC. And then there's also other licenses in the future if the school wants to purchase, if the advisors that are on or the mentors, you want to purchase licenses for the school to install on school computers, it's a different version of the license. So in order to get the discounted rate, you need your team number when ordering. This is provided in the award acceptance package. You'll email that to Apogee Rockets at the time when you, there'll be a box asking for comments, and the instructions are pretty simple. Just enter your team number. And then there's a limit to the number of discounted licenses that can be purchased. So keep that in mind. It's not infinite. It refreshes every year. And then if you need more, exceptions can be granted by Apogee Rockets. Our demo kit for today, we'll be using the Lock Precision Caliber ISP. This is our rocket kit that we use during the rocket workshops that we give, the Launch to Learn workshop. So you can see there's a screenshot of the rocket here with some specifics and then the price. So you can see price point. It's a level 1 kit. It's a single deploy rocket. Has a stock 54mm motor mount, 3-inch diameter. It's kind of standard. It's maybe a little on the small side for your competition rockets. Mind you, you will be using a dual deploy for your competition rocket, but this will be sufficient to demo today's Roxim. So just to recap, we've acquired and installed Roxim. So hopefully you guys all have Roxim or you're following along with your Roxim. We're trying to figure out how to install it right now. From Apogee Components, you start with the trial version, then you can upgrade to a licensed version. And then we've done some research, right? So I'm a team and I'm figuring I'm going to use Caliber ISP. I've looked at a number of rockets online. So that's the rocket that I want for my simulation. So the general user interface, when you open the Roxim, right, you get the quick action icons, just like any other program up on top here. You have some functional tabs, you have your working area, and then you have your rocket model window. Then how to load a model. You open the existing design file, and this is the box here. And let's see if we can get out of this now and get over to Roxim, and we will load a model. Can you guys see the RockSim screen? Are you guys still seeing the other screen?
We're still seeing PowerPoint.
How do I get to the RockSim screen?
You'll need to share, go back into share screen
Okay.
and switch which screen you're sharing.
Gotcha, got it. Thanks. There we go. So, as you can see in my Roxim, I am using the trial version. I have 2 days remaining. So I should probably activate that. I migrated it to a new computer. If there's any returning teams or veteran teams on the presentation as well, Roxim also recently upgraded to a new version 10. So teams from last year are probably still using a version 9. The upgrade to the version 10 is free. So Apogee's trying to make the version 9s obsolete. So go into the Apogee Apogee website and try and figure out how to get that version 10. It'll kind of ask you to submit your version 9 license, and it'll just exchange it for version 10, so that we're all using the same version throughout the course of the year, version 10. And then those are the new ones, you'll be getting a version 10. So we'll close this. We'll go to open a design model. Hopefully it works. Oh, there we go. So right away, Roxim takes you to their design library. I think probably because I had it open before, there's a Roxim 10 design library. And then you can see there's a number of manufacturers here. Apogee component rockets, Estes rockets, Lock Precision, Mad Cow, Quest, quite a number. There's a good 20 rockets in here. So we go into Lock Precision because the kit we selected, right, was the Caliber ISP. So we'll look, here's the Caliber ISP rocket here. And then we'll just open that. Notice it's a .rkt extension. So those are your Roxim files. Sorry, trying to keep up where we are. Oh, there you go. There's one right there. I also have one that's not built. I didn't think to bring it to show the components, but I have the individual components of the ISP. Thanks, Aaron. That was great. So that's a simple loading of a rocket into Roxim. So we'll come back to this, but right now we'll cut back to the PowerPoint. Back into presentation mode. So you see it kind of just walking through the presentation, kind of walks you through the same steps, how to load the rocket model. So you can see there's the ISP, and then there's a picture of the ISP. Importing rocket model. So although the Roxim is extensive, you may not, like I said, you may not find your rocket in the Roxim database. You'll have to import the model. You can download and import .rkt files from the internet. You could also create one from scratch, but that's usually for more experienced users. So we don't recommend that if you're a new team or new user. Some vendors include Roxim files on their websites, and a user-supported Roxim library can be found in Rocketry Reviews. So we'll make sure you guys get the link for that. So there's the Rocketry Reviews website on the left, and you can see you can filter by rocket type, and then it just has a bunch of different rockets that users have uploaded over the years. And then for the vendors, I use an example here, a Wildman Competitor 4 rocket. So you can see down at the bottom when you go to their website, there's a Roxim file. So when you click that link, it'll allow you to download and install a .rkt file for that Competitor 4 rocket. So to recap, we've opened an existing rocket model. We've examined how to import other rocket kit models. And then, although possible, we haven't explained how to create a model from scratch. This is more an advanced exercise. Is there any questions at this point before we get too deep? Hopefully you guys have all found your rockets and found your sims. I know in some proposals, I'm not sure teams have, all the teams have selected rockets yet. So maybe you're still looking for options. We'll get into the details now, the design attributes. So yeah, we'll cut back to Roxim. Okay, so the design attributes tab, this is the first tab you encounter. We need to make sure we've set that, configured that properly. So usually has the name. One of the important things here is the showing the CP location. We want you guys to use the Barrowman stability equations. You can see the other ones, there's a Roxim stability, and there's a cardboard cutout. So if you can see, as I'm changing from the Barrowman, it's basically determining, it's a way of calculating the center pressure. So when it's in Barrowman, it's a green. This is the center pressure icon. When it's in RockSim, it's red. Notice it's a little further back. Cardboard cutout is way forward. It's purple. So we find that the Barrowmen are most accurate. So please make sure your RockSim simulation is set to Barrowman, and that'll determine your stability margin. Number of stages. Again, RockSim's very powerful. You could do a single stage rocket, 2-stage, 3-stage. For this competition, it's always a single stage rocket. Static margin, nose cone base diameter. So again, just setting that as default. You guys are all going to have standard rockets, so just make sure it's a nose cone default for your design attributes. One other thing to note, and we can get into this, is the rocket viewing here. This, regardless of which tab you're in, notice the rocket view at the bottom doesn't change. So it's kind of constant. It changes when you change components or you change attributes. This will change down here. But these are also some important figures and statistics that we always need to know. The length of your rocket, the diameter, the mass, center of gravity, center pressure, and the margin. So center of gravity is this icon, this figure right here, and this one is center of pressure. So when you take our workshop, we'll discuss that in a little more detail with you guys. But for now, just knowing which ones they are and how to find the values for them, and the margin is right there. Next is the design component tab. So this is where all your components are listed or defined. And this is where you'll make all your changes, basically. So you'll kind of set the design attributes once, set it, forget it for that simulation. You might need to go back every time you open RockSim and make sure everything's correct, or you open a new model, make sure it hasn't changed on you. It's the design components you'll focus on for your rocket design. So you can see there's a tree here up in the working area, and the tree corresponds to the model down below. And the tree is spatially oriented. So the first item, the nose cone, is the first one on the left. The sustainer airframe is the second tube behind the nose cone, and the booster airframe is this tube at the back. And then you can see if you open each one, there's components inside of the sustainer, and there's components inside of the booster. And then, for example, further detail, right? We see the parachute in the booster. It's the first item in the booster. The shock cord is the second item in the booster. And then the motor mount is the third item inside the booster. So your rocket kits should come, or your model should, when you download it or install it or open it from RockSim, it should contain all the components, or most of the necessary components, in the proper order. Okay, that's great. So assuming the model's correct, we'll do a quick simulation just to show you guys how to simulate. Again, you can use the simulation dropdown and prepare for launch. You can use the prepare for launch icon. There's always different ways in every program. So we use the prepare for launch icon. And eventually the rocket model opens up. So in the simulation properties tab, you'll have 6 of these kind of tabs across the top. You're concerned with 4 of them: engine selection, flight events, starting state, and launch conditions. You don't always use simulation controls. You shouldn't have to change that. And we won't be using competition settings, so we won't look at that. But for engine selection, we'll go down. First thing you do is choose an engine or a motor. The terms are used synonymous. So you can see here, RockSim has a database of all these different engines from many different manufacturers. As you can see, there's like 12 different motor manufacturers. The primary ones I think we use will be Aerotech in the first station launch competition. So you can filter by diameter, you can filter by type. Some are reloadable, some are single use, some are hybrid. We're just going to put in an arbitrary motor, the 315. There's some other parameters here which are kind of trivial, that you leave you to explore those on your own. Ooh, there's a delay. So there's your motor loaded in the rocket. The little brown tells you that there's a motor now in there. You can see something's changed on the model window. Right now it has the engine, it lists which engine is in there. Also has the engine specs listed here. This one was new in version 10. It allows you to set the ejection delay in this window. So we can set that to 14 seconds for now. We'll talk a little bit about engine delay in a second here. So next we'll go to flight events. We want to ensure the flight events are basically your parachute or any electronic events. So your motor ejection at apogee is a flight event. Anytime you're triggering an altimeter to do a flight event, it would be here in flight events. So in the sustainer, there's a parachute, and we want to deploy it at, you can choose whatever parameter you're using to deploy it, max eject at a specific time. We'll simply deploy it at apogee. So make sure the simulation is set correctly. Sometimes if you have the flight event set incorrectly, say you deploy at an altitude, or you deploy at a time, 1 second, and then it's going to deploy on the way up. And then your simulation results aren't going to make any sense. So kind of make sure that this is set properly. Starting state. So one other thing to point out here is starting state, your launch guide length. I think when you first install RockSim, this will be set to 36 inches, which is 3 feet. And we need it set to 72 inches. So that's a standard high power rocket rail, is a 6-foot rail. And you'll see why we set to a 6-foot rail. Certain parameters come out of that 6-foot rail. You can change the launch angle of your launch rail. We don't recommend it. Leave it at 0. The Tripoli people will sometimes tilt the rail during a launch to compensate for wind a few degrees. But we won't allow you as a team to choose which launch angle you want. So just launch, simulate to nominal, like to 0. And then launch conditions. So you can, as you can see, there's a lot here. You can change all kinds of altitude, pressure, wind speeds, thermals, the height of the thermals. So say on the day of a launch, you're in Wisconsin, you're at the Richard Bong Park, and you want to put in the actual wind conditions or the actual temperature, environmental conditions. You could do that here. Just for generic simulations, just set something, it's, make sure it's all reasonable, nothing crazy. Setting everything to 0 isn't really the best either, because then when you come to launch, you're never going to launch at 0 wind or 0 altitude or 0 pressure. So put something reasonable in there for your launch conditions. So we'll close this window. You could launch from here. We'll go okay. So the launch function. So this icon right here is to run your simulation. So we'll hit that. RockSim does its thing, takes a couple seconds, and then it spits out run number 8 as your results. So these runs through 1 through 7 were just kind of with the program when it was first, like with the rocket kit when it's installed. So every time you change or save your model, it'll save all the previous runs. I'm Notice some of the team or the presentations were turning in multiple runs. If it's something that you don't know what the parameters were, or you don't like the engine, just go ahead and right click. You can delete all those trivial runs that you know nothing about, and just focus on the runs that are the runs that you've done, not the runs that came with the program. So this is your flight simulations tab. So notice now after components, we've set it up, we set the simulation conditions, we've launched, and automatically goes to flight simulations, which is your results. So we can see here the motor, we can see the altitude achieved, 5,900, velocity, acceleration. You can change which parameters are displayed in this flight simulations as well in the options and simulations. Velocity at launch, velocity at launch guide departure, which is a parameter we care about. So this is kind of a good number to know and report in your reports. And then velocity at deployment. So when your parachute comes out, you kind of want it to be not moving. You want the apogee to be 0. One of the things that you can use or look at that's important here is displaying details. So just right clicking on the simulation result and display details. And then it also shows you just a bunch of information here that's good to review your simulation. So some important ones are your time to burnout, your time to apogee. So that'll affect your delay on your motor eject. As we saw, we set it to 14. This rocket actually took 16 seconds to get up to apogee. Optimal delay, it tells you an optimal delay for your rocket. Another one we need to know is this one here, velocity at launch guide departure, 55 miles per hour. We usually quote that number in feet per second, not miles per hour. So you'll need a conversion there. I think that's it for this simulation details. So a few other ways to examine results is using the flight profile tab or icon here. So when you press this, it again runs some numbers and a little bit of a delay. And then it produces this kind of 2D flight profile. So you'll turn on the details and then you'll hit play. And it basically runs your simulation in a 2D kind of real-time model. You can see the timer's counting here in seconds. There's your rocket, and then there's all the parameters. So you can stop it at any point in time, and you can see the time, the thrust at that time, and all the parameters at that specific time. So say you wanted to do a flight event at a certain number of, it doesn't, because I don't have the full version, it's not going to do the descent. But if I wanted to do a flight event at, say, 10 seconds, so at 10 seconds in, I'm going to know that my rocket's still moving at 127 miles per hour. So maybe I don't want to do maybe I don't want a door coming off or something opening on the rocket at 127 miles per hour. Maybe I want it a little bit later at a different velocity. So you can use this. There's a lot of data in this 2D flight profile page that you can use to help in your design and choosing the timing of events. That's it for that. Another one to look at here for your results is plotting graph. And this is kind of nice for your reports. So you can go choose graph, and you can plot a certain number of parameters, CD versus Mach number, velocity versus time, a number of things you can plot. So time versus acceleration, time versus velocity. You'll just hit plot. And out it spits your velocity versus time and your acceleration versus time. So you can see the burnout happens here in about 3 seconds. And then the velocity and acceleration, of course, are falling off. I was going to have this as a pop quiz. What should the velocity and acceleration be at apogee? Anyone? You get a discounted license from Apogee Rockets.
The velocity,
Ideally, it should be 0, right?
acceleration should be 9.8.
Oh, okay. There you go.
It should be G. I don't know the feet.
Right.
Squared one.
Yeah. So acceleration, G's, and velocity, right? So again, you can also change the acceleration units. And that also brings to mind one other thing. I think you can set your units in RockSim, but in your reports, like throughout the year, be consistent in your units. So if you're using inches, right? So you can see in our display here, it's inches and ounces. Try to be consistent. Always use the same units to discuss your payload or to discuss your rocket or to discuss anything else. So if you decide you want to use grams, that's fine. We're not going to dictate which units you guys use, but just be consistent. It's very difficult to read a report when the units are switching a lot. When your mass is quoted in grams 1 second, and then the next paragraph, your mass is quoted in a different unit. So make sure your units are correct. So I think that's it for simulations. We will go back. That's one. So we can see the PowerPoint basically just kind of covers all we just discussed: simulations, flight profiles, displaying details, 2D model, the 3D flight profile, and then graphs. So then to recap, so in the past 5-10 minutes, we examined the essential tabs and functions of RockSim. So we looked at the design attributes, the design components, we prepared it for launch, and we run a flight simulation and inspected the results. So, within 5-10 minutes, we've successfully simulated a stock rocket kit flight. But no, we've also selected an arbitrary motor with no concern about the performance. So as we go on the rest of the presentation, we're going to look a little more on, what the performance is and how the effects of it. So that's kind of the goal for you guys, is not only to select the kit, but select the proper motor, such that you reach the 3,500 foot altitude and you don't exceed any of the other parameters in the handbook. Any questions at this point about how to load a motor or how to load a rocket or any of the attributes, components, preparing for launch? If not, so we'll talk about modifying the simulation to achieve your challenge goals. So most high-powered rocket kits are not typically designed to accommodate a challenge payload. We'll see that in a bit when we have to modify the sustainer section. So you'll need to modify your rocket. You may need to add sections. You may need to delete or remove sections, or just modify something in both your simulation and then physically to incorporate your challenge. And then also making sure your kit is accurate, making sure your model is accurate. Not all the models, right? Like you could assume the model's correct and then you go and purchase the kit, it shows up and some things are different on the kit that aren't in the model. So making sure that those models, the physical and the simulation, kind of match each other as best they can. And then keep in mind during procurement, kit components can usually be exchanged. Just communicate with the vendors, the rocket vendors. I've purchased rockets where I've decided to change a fin or change a motor mount. It's very simple. You're not stuck with what that kit is. The manufacturers will work with you to get you what you need. We'll look at adding components in RockSim. So let me get back to our Roxim model. Okay, so this is a nice model and all, but the stock model is missing some components. So I can see right off the bat, and maybe not as super evident to inexperienced rocketeers. This rocket's missing the rail buttons. It's also missing some components on the interior, such as the motor mount. There should be a mast back here. It's missing a centering ring and a eye bolt that will ultimately be living right around here. So these components will affect the performance of the rocket. So we want to make sure that all the components are in the model. So we'll go back to the design components, and we're going to just add, a motor retention. So we'll make sure to highlight the section. We want the motor retention to be living in the booster airframe, kind of behind the fin set here. So we'll go, and these, oh, they're hidden behind this thing. These are the components basically you can add. Adding new components, a tube, a mass object, a parachute, streamer, coupler, basically anything you need in your rocket you can add here. For internal components such as a motor retainer, we're just going to add a mass object. So Roxim opens the database of all the different mass objects. You can see there's eye bolts, quick links, there's engine retainers. I'm going to choose to install a 54mm aero pack. So it brings in the aero pack, it brings in the mass. So Roxim knows that the mass of that component when I purchase it is 2.2 ounces. And then I just need to place it in the proper spot. So I'm going to go and put it right at the very back. There you go. There we go. We've just added a component. And we can continue to go on and add other components. We can also add in the booster section, adding a forged eye bolt. Same thing, it knows the mass. Again, you should check it, right? If you go out to this Home Depot somewhere and you purchase eye bolts and they come back and it turns out they're twice the mass, then, you know, try to update your model as accurately as possible by weighing your physical components. So we'll go put that one right about here. Okay. And then adding rail buttons. So again, on the booster section, we'll use a launch lug database. Not every rail button is in this database. In fact, these are launch lugs, which are kind of not what we're looking for. So make sure you understand the difference between what a launch lug, a rail button, and a rail guide. Those are three different things. They kind of sound the same. They're synonymous. We want rail buttons. Launch lugs are okay, but for this example, for now, we're just going to put a rail guide in. So again, put it right around here when we install it. This one, you need to choose the material. So make it polycarbonate. And then we also need to choose a radial position, because right now that rail button is in line with the fin and you want it to be sitting between the fins. So on a 4-fin design, 45 degrees, put your launch lug off to the side. So go okay. So there's some updated components. And then you'll actually need 2 rail buttons. How am I doing on time? Ooh, geez. We're not gonna have enough time. This one at the back. 45. Oh, forgot the mass. All right, so we made some modifications to the rocket. We've added some weight, and we've created some drag on the outside. So we could rerun that. The motor's still in it. We just need to go hit the launch button and it reruns. So notice now we've lost some altitude. We've added a few ounces, maybe 2% of the total weight, and we've lost about 100 feet in altitude. And all the other parameters have also decreased. So our velocity's decreased, the acceleration has decreased, and the velocity at launch log, our velocity at launch guide departures decreased. So you can see with the effect of weight, like any little weight component that you forget to put in the model will decrease your values. So that's why we say make sure all of your components are in your rocket, are in the model. And then one other thing we'll look at is modifying a component. So we'll go modify the sustainer airframe for the payload. So we're going to say, we're going to say this is a 14-inch tube with the shoulders. Maybe there's 8 inches in here. So I'm going to say maybe my payload needs more than 8 inches. Maybe it's 12 inches long. So I need an extra 4 inches on this tube. I'm just going to go highlight the tube, go to edit, and then just add 18 inches. And then also make sure when I order the kit, tell the manufacturer that I want an 18-inch tube in addition instead of the 14-inch tube. Another thing to notice here is changing the finish. We're going to change it to matte, a matte finish. You can see there's 4 different finishes. It's highly unlikely that your rocket's going to be polished. This affects the coefficient of drag. So a polished rocket will obviously go higher because there's less friction on it. Unfinished rocket has a higher coefficient of drag, so it goes lower. So somewhere in between, either gloss or matte would probably be your rocket finish. So we'll update that to matte. And then close this box if I can figure that out. And then in the sustainer as well, I'm going to want to put a payload. So I don't want the database because I want this just to be challenge payload. This is going to be maybe a 16 ounce or a 12 ounce. No, we'll say it's a 2-pound payload. And it's sitting in the middle of our sustainer. So this is my challenge solution now, whatever that is, whatever that it's going to occupy this volume and it's going to weigh that mass. Early on, right, you're not going to know what the volume is, or you may not know, you might not have an idea, but by preliminary design, especially by critical design, you should know what the size of that payload is, how much space it takes up and how much it weighs. So again, now that we've made some changes, we'll relaunch. And you can see we've lost again from the original 500 feet in altitude just by adding our payload. So that's that for modification. We'll go back to PowerPoint. The PowerPoint, right, you can see our motor retention. There's a picture of the motor retainer I installed. Launch lugs, those are the rail buttons we talked about installed. Modifying the airframe, right? So you've extended the length. You may also want to decrease the length. So you say, look at the booster section. You say, why am I carrying this extra mass when it only needs, our parachute's only taking up 4 inches. So the booster might show up and you decide to cut off 6 inches. So you could do that as well. You could reduce the size of components. Use mass objects for everything, your estimated payload mass. So we've added some design components. We added the motor retainer, which is weight. We've added rail buttons, which is drag. And then we've added the payload, which is weight. We modified the airframe, which is weight. And then we modified the airframe finish, which is drag. Any questions on that? Adding and modifying, that's all you're doing. You're looking for a base kit. You're going to start adding and modifying and selecting a motor. For the sake of time, we've only got 10 minutes left. I guess we're close. So one of the other things we want to bring up, make sure you guys understand and think about, is the mass override tab. So it's the third header, the third tab, and this is for vehicle level. So you want to make sure this box is not checked. So use the values shown below. So it's kind of a feature where I would assume that RockSim provided it. If you have a built rocket that you've never simulated before, and there's no way you can weigh the individual components, you can put in a single weight for the entire rocket if you know where the center of gravity is, right? So it also needs the CG values. So ensure that this box is not checked. We don't need to use this feature. Sometimes by accident, by mistake, someone's playing around, they turn this on, and then all of a sudden your rocket starts simulating weird. It starts running and crashing or no results, or you can't figure out why when you're changing your components, you know, nothing's changing. Your mass isn't changing, or maybe your weight, altitude isn't changing. Just make sure this mass override's not turned on. So you want that box off. And then another feature is mass override on the component level. So as you saw when we went into the body tube, hopefully, you can see that the mass override is on. So the way that RockSim works, it takes the volume of the component and it knows the density of the material and it calculates a mass. Sometimes RockSim could be wrong. You know, you could have the component sitting in front of you and you weigh it on a scale and you don't trust this 10 ounces. You say, hey, maybe this is, you know, it's only 8 ounces. So then that's when you would go and use a component mass override. So you'd go to the mass override tab, you would check the box, you'd put in the mass that you determined by weighing it, and then you'd put in the center of gravity of that component as well. So usually the CG is kind of the middle of the component, right? So the CG of a tube will be the exact center of that tube. So you take the, you know, whatever it is, 17 inches, divide by 2 as your center of gravity. So another thing to check when you download or install a model is make sure that the mass overrides are not turned on. So early on when you're simulating, try and use the calculated mass, not the mass overrides. And then conversely, the coefficient of drag, the CD override is the next tab. You want this one turned on. I don't know why RockSim has one off and one on. They should both be on or both off. Seems counterintuitive to me, but so you want RockSim to calculate the CD at simulation time. If you turn this off, it's going to use these values. And I guess as an advanced feature, if you could figure out the coefficient of drag of each component, you could use the coefficient of drag override. But I would let RockSim calculate the coefficient of drag at each run. And then look at dual deployment. So we looked at a single deployment rocket. As you can see here, this is a dual deployment rocket. It's a little more advanced, a little more complicated. They're usually bigger. This will be your rocket, right? You guys will have dual deploys. We can see some features in here. It's more than 10 feet long. This is a big rocket. It's a Wildman 6-inch. It's a 6-inch diameter, 48 ounces. What is that? 30 pounds about. Very big rocket. So you can see some major differences from the single deploy. This one has 2 parachutes. There's one parachute here and one parachute here. So there's one parachute in the booster and one in the sustainer. And normally you want the drogue parachute in the booster and the main parachute in the sustainer. That's a standard configuration. It could be, you could change it up. You might have other ideas how you want your configuration. Make sure to put those in your report so we can approve those as we go. This is the airframe section, or the avionics base section. There's the switch band. And all these little mass components are altimeters, batteries, and the hardware needed for your electronics. Other than that, you know, you can see the fin's the same, the motor mount's the same, the center rings are the same. It's the same. It's got a CG, it's got a CP, and then all these other eye bolt components and other components. So recap, vehicle level mass override is bad. Component level mass override is okay if you use it sparingly. Vehicle level CD override is bad, so don't use those. Dual deployment is also more detailed and challenging than single deployment. Any questions on that? Hopefully everybody understands all that. Perfect timing. All right, so simulation process. So for your design steps, right, you should be estimating the size of your challenge solution. You'll need a weight and a volume. And then you select an existing kit that will accommodate your payload. So try not to do it the other way. Some teams or some students will pick a kit, they'll pick a 4-inch, and then over the next couple weeks or months, they'll try and fit their payload into that 4-inch. You kind of want to do it, you don't want to constrain your payload. You want to, because it's easy to step the rocket from 3, 4, 5, 6. It's very easy to change the rocket. It's not so easy to change the payload, like the challenge, right? So after, say, you constrain it to 4-inch rocket, say 8 weeks in, it's determined that your payload has to be a 4-inch or a 5-inch, has to be 1 inch bigger. Now you've done all that work, right? So estimating that payload challenge is the first step, and then you select an existing kit that'll accommodate the payload. So then you import it into RockSim, sure all the components are there, and select the motor that achieves the technical criteria. And then you iterate over every design cycle. Any questions on that? Hopefully you guys have been doing that. And then some simulation tips. Try and incorporate all the components in your simulation as early as possible. Update your simulations weekly, bi-weekly. Note that your final kit should be selected before CDR phase, and your final motor selection is due at the start of CDR. So because your final motor selection is due, all your components should be selected at that point, and there shouldn't be any design changes after that point. It should all just be building at that point. CDR is a build phase. The next one of the FR is a flight phase, like a test phase. So that's all we got. There's some resources for you. The trial version website, the TARC. Thrust curve has some motor data. Rocket reviews are where you find that RockSim library. And then there's Aerotech, which is a motor manufacturer. You can see specs on the motors. And then some kit manufacturers. We listed Public Missiles, Lock Precision, Mad Cow, and Wildman. That's all I got.
Thank you very much, Mark. Can you hear me?
Yeah.
Oh, perfect. Just want to thank you. That was phenomenal, very detailed, great presentation of RockSim. Does anybody have any questions for our team? If not, I do want to thank you for attending. Connie or Danielle, if one of you are on, would you mind telling us when the next workshop webinar is going to be and what the topic is?
Sure, I can talk about it. Excuse me. So our next webinar is going to be on January 12th, and it's going to be covering avionics and altimeters.
And do we have who is making that presentation for us?
That would be Shane Justice from Raytheon.
Yes, I don't believe we have a time yet though, but it is Shane.
Very good. So we will get that information out to you as soon as we have that available. Otherwise, I hope things are going well. And does anybody else on the team have information for anyone attending? If not, have a great rest of your day, and we look forward to having you come back to the next webinar. On that note, goodbye, everybody.
Bye, everyone.
Thanks, Mark.